Alright guys, bear with me, but I'm doing this video from home, so the audio probably isn't quite the same quality as what you're used to at school, but I think it'll serve its purpose. So here we go. Number one, during a figure skating routine, Jackie and Peter skate far apart with an angle of 15 degrees between them. So, and one goes 5 meters, the other goes 7. So I'm going to kind of draw that triangle out. I'm going to do Jackie going 5 and Peter going a little further, doing 7. And the angle between them is 15 degrees. And then the question is, how far apart are the skaters? So we're trying to figure out this third side, how far apart is that? So I think the easiest thing is going to be, you're going to want to put some letters on here, just so you can follow your law of sines or law of cosines. So we're actually looking for little a. I'm just going to call this b, which would make the 7 little b, c little c. All right, so since we need a little a, I'm going to use the little a equation. And I'm not going to keep rewriting this throughout the entire video, but I'll write it here in the first one. You guys should have copies of this written down in many places by now, but I'll write it out this first time. The big thing to remember is when it starts with the little a for a side, you need the big A on the other side, so you know you got it set up correctly. So let's just plug and chug. Let's just put everything we have in here. So I got a squared equals 7 squared plus 5 squared minus 2 times 7 times 5, all times the cosine of 15 degrees. So I've already kind of worked these out on paper with a calculator, so it should speed up things a little bit. So that's 6.385. The directions don't really say, but we're going to round to the nearest tenth. We've kind of been doing that all the time, so if it's never not on the directions, always assume we're rounding to the nearest tenth. But I need to take the square root of both sides, so I'm going to do that really quick. And I get a equals 2.526, so we're going to call that answer 2.5. All right, moving right along. Number 2, a bridge is supported by triangular braces. The sides of the braces are 63, 46, 40, so we have all the sides of the triangle. We need to find an angle opposite the 46. So right away, I know I'm going to use the inverse because I'm trying to find an angle. So let's sketch this triangle out. And it really doesn't have to be perfect to scale. Just get your numbers right. So we have a 46, we have a 40, and we have a 63, the big dog. And we want to find the angle opposite the 46. So we're basically trying to figure out that angle right here. I'll call it theta. Or we can use letters. We'll use big A, big B, little b, not C, and then big C, little c. So I need to find angle A, because that's opposite the 46. So let's use the A equation. So we're going to use the a squared equals b squared plus c squared minus 2bc, all times a cosine of big A. And we know everything except for big A. So I know one of the sheets I gave you on the back side on that cheat sheet, I kind of already solved for the cosine of A for you. So I'm going to kind of set that up. So we had a squared minus b squared minus c squared, all divided by negative 2bc equals the cosine of big A. And that just kind of sets it up nice. So now I can start putting numbers in. And let's put some numbers in here. So we have 46 squared, take away 40 squared, take away 63 squared, all over negative 2 times 40 times 63 is going to equal the cosine of some angle. And when I put all that into my calculator, on top, I got a negative 3453. And on the bottom, I got negative 5040. And then to find angle A, you basically have to do the inverse. You have to do the inverse cosine of all that crap. And That's going to come out to be, I got 46.755. That's a 7. So we'll call that 46.8 degrees. There we go. Number 3, two observers are standing on shore a half-mile apart at points A and B. They measure the angle to a sailboat that's at point C. They give us the A and B angles. So let's kind of sketch this out. So we have a person here at A, person here at B, and they're on the lake or on the shore here. And then they're looking out into the water, and at point C, there is some sort of sailboat out here. And it says angle A is 63 degrees, angle B is 56 degrees, and then they say that they're standing a half-mile apart. So if I find my answer, it's going to be in miles, and it's going to be a decimal, and I could probably do that. Might be easier to do it in feet, so I think I'm going to do it in feet, but if you wrote it in miles, it wouldn't be wrong. You could also do that, but I'm going to use this little calculation that 1 mile is 5,280 feet. So I know that half of a mile is half of that. So that'd be what, 25, 2640, I believe. 2640. So I'm going to put that down at the bottom. 2640. The thing that people kind of forget about is we can find angle C. You know, we have A and B, so if we add A and B together, we have, sorry, this laptop's kind of touchy. If we add them together, we have 63 and 56, which that's 119. So subtract from 180, that tells me that I have 61 degrees up there. So that kind of helps me because I can do the law of sines. So it says find the distance from each observer to the sailboat. So we kind of are looking for both pieces here. We're kind of looking for little a and we're looking for little b. So I'm going to kind of do the law of sines twice. So here's a ratio that we know. We know that we have sine of 61 degrees over 2640. Now you could have put in 0.5, but then your answer is going to be in miles, and it's going to be a decimal mile, which is kind of weird. That's why I changed it to feet. But you didn't have to. So if I want to find, let's say, little a, I'm going to do the sine of 63 over little a. And just to kind of save time and not write out every single step, basically I'm going to multiply these two together, and then I'm going to divide by what's across from the a. And when I did all that, I ended up getting a equals 2689.5, which makes sense because it should be a little bit bigger than what's across from 61 because it's 63. So that makes sense. And now to get little b, I'm going to set up a similar equation. I'm going to go the sine of 61 over 2640 again. But then to get little b, I'm going to do the sine of 56 over little b. And since 56 is a smaller degree, I know I'm going to get a side length smaller than the other two. At least that better if I did it right. So I'm going to multiply these two together. I'm going to divide by the sine of 61. And I ended up getting b equals 2502.4. So just a law of sines problem for that one. Number 4 was kind of challenging. There's several ways to do number 4. I'm going to try to give you the easiest way or the fastest way. And I don't think you really need law of sines or law of cosines for this one. I think you can use special right triangles. And I think you also can use SOHCAHTOA to knock this one out. So here we go. I'm basically going to use this big solid black line down at the bottom for the ground. And I have a building right here. And then on top of that building, we're going to put a flag. So I'll put a flag right up here. Make it nice and pretty. Old Glory flying. And then we have our person. It says a man stands 400 feet from the base of the building. So I'm going to put the guy way out here at 400 feet from the building. From his viewpoint, the angle of elevation to the bottom of the flagpole is 60 degrees. So to the bottom of the flagpole, that angle right there is going to be 60 degrees, which I know it doesn't look like it with the picture, but bear with me. And then the angle of elevation to the top is 62.5. So we have another little 2.5 degrees in that little sliver. This one was just plain old 60. Kind of crappy, so maybe I'll try to get in there and erase that. Make it a little bit better. It really makes me appreciate the board at school. All right. So ultimately, I'm looking for H. I want to know how tall the flagpole is. But I think I'm going to first, there's this X here that's kind of going to be the height of the building. And I think another thing that this is just me, I mean, there's other ways to do this, but I think if I look at the giant triangle here, I'm going to call that Y, because there's kind of two right triangles over here. And I think I can do a tangent a couple different times and maybe get this one. So first thing is, if that's 60 degrees, I know that this is 30 degrees. So I have a special right triangle of 30, 60, 90. And even though my picture's drawn kind of goofy, across from the 30 is 400. So that's the baby side. So I know the side across from the 60, which is this X actually. This X is going to be the middle side of the freak. So X is going to be 40 times the square root of 3. You also could use SOHCAHTOA to find it, but 40 times the square root of 3 came out to be like 692.8. So that's this, whoa, don't know what that did. That's this X right here, 692.8. And then I'm going to use a tangent, and I'm going to focus on this big triangle. I'm going to focus on this whole thing. And I know that that angle that I'm standing on is actually 62.5. And I'm going to use the 400. So this is my adjacent. Y is my opposite. So I'm going to use TOA. I'm going to use tangent. So the tangent when standing on 62.5 degrees is opposite over adjacent. I'm going to slap a 1 under there. Cross multiply. This will be beautiful because I don't have to do anything else. I just have to times 400 times the tan of 62.5. And I got 768.4. So Y is 768 not degrees, just 0.4. So basically I have the entire side, and then I also have X. So I think to get H, I can just subtract Y minus X. So I think Y subtract X is going to give me H. So when I do 768.4, take away the 692.8, that gives me a grand total of 75.6 is the height of that flagpole. Now, if you forgot your special right triangle stuff in the beginning, you could have, so an alternate way would have been to do the tangent of 60 degrees is opposite over adjacent, and you could have cross multiplied, and that would have given you this. I just used the shortcut because I remembered it from the special right triangles. Now, there was other ways. I did this It's school, and I had it solved, and I know I used the law of cosines or the law of sines, and I used that 2.5. But when I got home and I didn't have the answers and I redid it, it just seemed easier to not go down that road. But if you want to see it that way, just ask me in class. Number 5 on a map, Orlando is 178 millimeters due south of Niagara Falls. Denver is 273 from Orlando and 235 from Niagara. Find the angle at Niagara. So that's all really confusing, man. You can't just try to solve it yet. You got to draw it out as you have it. So Orlando is due south of Niagara. So I'm going to put a dot here. I'm going to put NF for Niagara Falls. And straight south, 178 millimeters, is Orlando. So I'll just put an O there. Maybe I'll put an OR. And then Denver, and I know Denver's out west, so I'm going to kind of draw it accurate. Denver is 273 from Orlando. So let's just kind of put a D out here for Denver. It's 273 from Orlando, and then it's 235 from Niagara. And it says find the angle at Niagara. So basically we're trying to figure out, this angle right here. That's what we want. So if you want to label A's, B's, and C's, if that's easier for you, you could do that as well. Maybe I'll do that just because it's what we've been doing. So there's big A, little a, big B, little b, big C, little c. It doesn't really matter where you put stuff as long as you can set up your law of cosines right. So I need the big A. So I'm going to use that equation that we kind of had already set up from before. So it was A squared minus B squared minus C squared all over negative 2BC equaled the cosine of big A. And let's put everybody in there. 273 squared, take away 235 squared, take away $1.78 squared, all divided by negative 2 times 235 times 178. That's going to equal the cosine of A, which we know we're going to use the inverse here in a second. When I jammed all that crap into my calculator, I got negative 12,380 on top. I like to write these numbers down because if I miss this problem, I'm not going to know why I missed it. But if I write these numbers down every step of the way, I kind of can figure out where I went wrong. So when you get it wrong, don't erase all your work. Just start somewhere else. Leave your old work. Heck, it might have just been a negative sign or something that you screwed up on. So I'm going to inverse cosine all that crap. And that shakes out to be, I got 81.5 degrees for angle A. So number 6, Nicole shines a light from the window of a lighthouse on a cliff. Man, I hate it when they do all these weird type of things like this. So she shines a light from a window of a lighthouse on a cliff 250 feet above the water level. So first off, let's get the water level. Kind of draw that. So I'll put blue down here for the water. There's a cliff. So we have some sort of a rocky cliff here coming down. Then we got a lighthouse. And then we got Nicole chilling up here in the lighthouse, shining a light down for some reason. Nick is 10 feet above the water level in a ship off the shore. So I'm going to draw a boat with Nick standing on it. And he's standing 10 feet above the water. So a pretty big ship. Definitely bigger than the way I've drawn it, but whatever. The angle of elevation to the light is 3 degrees. And they don't really say from his eye or anything. So I'm going to assume it's from where he's standing. That's just usually kind of safe to assume. So it looks like coming up here, And I got to draw this horizontal line, the 10 feet above water for the ship, is 3 degrees. So we got an angle in here of 3 degrees. So this is 90. If I needed to, I could put the 87 up there, but I don't think I'm going to need it. We need to find the length of the line of sight. So we actually need to find this hypotenuse here. We need to find this x, how far that is. One thing we do know is she shines a light from a window of a lighthouse on a cliff 250 feet above the water. So where that light is coming from is 250 feet from the water, which is all the way down here. But then there's 10 feet there. So really in our little triangle, it's 240. Man, this laptop's touchy. Hitting all kinds of weird things here. So this is 240, not counting the 10 feet above the water. So I think this is just, this is just a straight up SOHCAHTOA problem. It's a right triangle. If this is my guy, if my reference angle is over here, 240 is the opposite. X is hypotenuse. Let's just use sine. So the sine when standing on 3 degrees is opposite over hypotenuse. Slap a 1 under there. Cross multiply, I get 240 equals x times the sine of 3 degrees. Divide both sides by the sine of 3 degrees. And I ended up getting, I think I dropped my piece of paper, and x works out to be 4585.8. Now, I know that seems like a big number, but 3 degrees is dinky. I mean, if you're 240 across from 3 degrees, across from 90 degrees is going to be much larger. So even though it's a big number, I think it makes sense in this situation. Number 7, fire towers A and B are located 10 miles apart. A ranger at fire tower A spots a fire 42 degrees, and then B spots it at 64. How far from tower A is the fire to the nearest tenth of a mile? So I'm going to set it up. I have fire tower here is at A, fire tower over here is at B, and out here somewhere they spot a fire, roaring out here somewhere. So we're going to call that point C, where the fire is. And I'm going to triangulate it. So I got my triangle going on. And it said the rangers at Tower A spot a fire at 42 degrees. And then at B, they spot the same fire at 64 degrees. And how far is A to the fire? So basically from A to the fire, that would be little b. So we're kind of trying to find little b here. The one thing that I didn't write down is that they're 10 miles apart. So A and B are 10 miles apart. And you might feel like you're kind of stuck, but remember we have 2 angles, so we should be able to figure out the third angle. So when I add 42 plus 64, that's 106 degrees. So to get to 180, we're like 74 degrees short. So I'll slap that up there. So I think this is a law of sines problem. I can do 74 across from 10, 64 across from B, and get after it. So the sine is 74 degrees over the side across from him equals the sine of 64 degrees over little b, which is the distance from A to the fire, times these two, divide by the sine of 74, and I ended up getting b equals like 9.35 miles. So I'm going to call it 9.4. All right, hopefully this video helps you out on the ones that you were stuck on. I think the hardest part's getting the picture drawn. Once it's set up, it's not too bad, and you'll just get better, more and more practice, getting your reps in, seeing similar problems over and over and over. See you.